All right, let's go back through a little bit of a reflection. We've used our trig ratios and we've used them to solve problems using right angle triangles. Now, that's really useful when we have a right angle, but what happens if we don't? Okay, so if we don't have a right angle, how are we supposed to solve our triangles? Well, here's a triangle, okay, that we're given two angles and we're given a side. Can we solve for our other sides? No, not really, okay, because we don't have a right angle. Oh, wait a minute, this could be a right angle, couldn't it? Well, we know that to find our third angle, we can subtract our other two. And so that would mean that this angle right here would be 58 degrees. Okay, it's 58 degrees. Ooh, okay, there's no 90-degree corner in there. This is an acute triangle. And so, yeah, we're kind of stumped. We can't actually find, okay, the angles or the sides because we don't have a right angle. So without a right angle, the trig ratios cannot be used. Okay? Not at all. We just can't use them. But we can use the idea of two triangles put together to actually determine a law which will help us to solve a triangle without using a right angle. Let's use the label triangle to show proof of our sine law here. So here we have a triangle. We have ABC, triangle ABC, with A being this long side, B being this side, and C being this side right here. Now, in this case here, we're going to not use any letters or numbers. We're just going to use letters. And I'm going to use this, this piece right here from A to D as a guideline and split this into two right angle triangles. So I'm going to observe two angles in this case here. I'm going to observe C and I'm going to observe B. Okay, these are going to be my two angles. I'll give that one theta and I'll call this one beta as being my two separate angles. And I'm going to solve for those. I'm going to use these two angles. So imagine that I had these angles to solve for this side right here. Okay, so I'm going to solve for this side right there. There's my little question mark. Now, if I'm going to start with angle C. With angle C, if we're given angle C, then there's a couple things that we will know. We know that B is our hypotenuse. This is our opposite side. And down here, this is the adjacent side. So to solve for the opposite side, so let's say I want to solve for the opposite side, I can come up with a little equation here, and I'm going to say sine of C is equal to the opposite, which I don't know, which is, so line segment AD. Can I do a line segment here? Just want to double check. I don't think so. Okay, just trying here. So line segment AB divided by B. All right, so line segment AD divided by B. Now, what I want to do in this case here is I actually want to solve for AD. So I'm going to actually solve for AD, get that all by itself by multiplying B to both sides. And so line segment AD is equal to B times, actually I should do the little dot instead. I'm sure that, maybe not. Okay, I'll probably have to use a time symbol then. Times sine of C. So AD is equal to B times sine of C. I'm going to stop there. I'm going to move on to my second triangle right here. I'm going to move on to this one here, where I'm going to use B to solve for AD. Okay, so I'm going to use B to solve for AD. All right, first things first. Well, let's use a different color, actually. Let's use green. This is going to be my hypotenuse. This is going to be my opposite. And this side right here is going to be my adjacent side. So with these three sides here, to solve for the opposite, I have the hypotenuse. So I'm going to again use sine. So sine of B is equal to the opposite, which I said again was AB, over little c. And to solve for AD, again, I'm going to multiply by c to both sides. and sine of b. I move the ABs over to the other to the left hand side. It's a little easier maybe to see, but I know that in this first case, this side right here will be sine of c times b, and to find the same side, I can do sine of I can do little c times sine of big B. So that means that this right here with the C and this right here must be the same thing. They must be equal to each other. Okay? So that means that those two must be equal to each other. So what I'm going to do then is I'm actually going to use that to come up with another equation here. So I'm going to say that B times sine C must be equal to C times sine B. Okay, they must be equal to each other. I'm going to go one step further, and I'm going to actually divide both sides by B and both sides by C. What's going to happen is it's going to get rid of the B here and get rid of the C here. And by doing this, I'm going to get sine C over little c is equal to sine B over little b. And here, now this might not look like a whole lot, but this right here is going to be our sine law, and it's going to help us actually to solve for certain pieces based on stuff that we know. So, given a triangle as shown below, the sine law can be used to find different angles and sides. And we're going to extrapolate a little farther. We know it works for B and C, but we're going to actually add A in there as well. So sine A over little a is equal to sine B over little b, which is equal to sine C over little c. Okay? These are all equal, so these are equivalent ratios. Okay, just like we found up here. So in our first lesson, we found that for every single time we do this, it's always going to give us the same number or very close to the same number, depending on how well we measure. We can know that when we do it for an actual triangle, it's actually going to always equal the same thing. So we can use these as similar ratios to solve for questions. Now, you'll notice here we have the signs on top. We can also flip that around if you want to do sine A is equal to B over sine B, which is equal to C over sine C. This equals exactly the same thing. Okay, these are equivalent. It works exactly the same way. It all depends on which one you want to have on top. So this is sine law, and we're going to use sine law to, again, find certain angles and certain sides in a non-right angle triangle. Now, there are some limitations, and we'll get into that in just a little bit. But for right now, we're going to take a look at, we're going to go through how do we solve certain values.